Okay, so thank you all for coming. I'm here to talk to you about Xen Dom0-less, which is a new way of using Xen for static partitioning scenarios. But to understand how that makes a difference, I'll start by the classic way of using Xen. So normally, you have U-boot or another bootloader that boots Xen. Then boots Dom0, first the kernel, then userspace. Then fully booted, you have the Xen tools available, specifically Excel, the principal tool you interface with as a user. And you can use Excel for doing a number of operations on the platform, including, of course, creating additional VMs. Now, this has a series of consequences, some of them good, some of them not so good. So the first consequence is typically Dom0 and Xen are only for platform management, right? So your critical application, what you really care about running, is going to be either in the yellow or in the purple VM. So if we think about how long it takes to get your critical application or your important application up and running, it's going to be at least as long as Xen booting plus Dom0 booting both kernel and user space. That's just by necessity of how the boot sequence works. And Dom0, I mean, you can try to trim it down and configure it properly, but typically it's based on Linux. Doesn't have to, but like 99% of customers use Linux at the end of the day. So, and it's typically, I mean, not a big system, but even if you configure it down with Yocto and so on and so forth, it will take a few seconds. So I think on Xilinx and Petalinux, which is a distro we use for Xilinx boards, it will take around not 10, but maybe more than 5 seconds, which is not great for like a critical application that needs to come up and running maybe in a split second to be able to control some robotic arm or some kind of industrial function. That's one consequence. Another consequence is safety, right? Dom0, because it's running the Xen tools and mainly Excel, but others, it has a certain level of privilege over the platform, which is able to, for instance, reboot the old machine, right? So if one of your two VMs, like the yellow or the purple VM, are safety critical, and you safety certify both your critical application and Xen, so the Xen hypervisor, it's small enough, it's 50,000 lines of code. I mean, all the safety body we talk to, they believe is certifiable. So let's say that you even do that, what about Dom0? Dom0 is based on Linux. It's going to be difficult, if not impossible, to certify. All the Xen tools also then need to be certified. It's difficult, right? So there are solutions. For instance, one of them is to have Dom0 quit after boot. This is just a simple idea. You get Dom0, create all your VM, and then get out. Now, if you do that, you have the advantage that Dom0 is only present at boot time, not at runtime, and that has a very different profile for safety certifications. Another idea is to use another operating system for Dom0. Again, most use Linux, but you don't have to use Linux. There is nothing really Linux-specific in this architecture, so you could use anything, including at small RTOS, like FreeRTOS, you could use a proprietary OS. You can mix and match. But then the Xen tools are mostly developed and tested under Linux, so it will take a bit of an effort to maybe write your own tools or port the tools. But, well, you also need then to build all the Xen tools in Dom0. Like, it's not just a matter of taking Xen and using it to split your system into multiple domains. The Xen tools need to be of the same version of the Xen hypervisor. They always come as a matched pair. So when you pull in a new Xen hypervisor, you can build that the same way you build a Linux kernel, but then you need somehow to rebuild the tools to match the version, which is always a bit of a problem. Now, these are all cons. What's the pros? The pros is that Dom0 is a great monitoring tool. So you can use it to monitor your VM. You can use it to deploy new VM at runtime, hot plug devices. You can reboot VMs. So it's a really, really powerful infrastructure. What I'm going to talk to you about now is a scenario where you don't have Dom0, or Dom0 is not as important as before. In this scenario, what you do is you use U-boot to load Xen in memory, like you do today, to load the Dom0 kernel and RAM disk in memory, like you do today, but then you use U-boot to also load the kernel and RAM disk of your yellow and purple VM. Now, after that, what you do is you have U-boot boot Xen, as usual, but then Xen would boot DOM0, yellow, and purple all in parallel on separate physical cores. Now, the consequence of this is the time to boot your yellow VM now is just the time to boot Xen, and plus your application-specific boot time, of course. But, so if you have a very, very small bare metal application to control a robotic function of some kind, it will probably boot up in a few milliseconds. Right now it's only these few little milliseconds, plus the boot time of Xen, which is already slightly less than a second, I would say, but it can certainly be easily optimized further. You have only one thing to basically trim down. So you go from almost 10 seconds to basically 1 second, easily. Now, I say DOM0-less, but in reality today, this is, I use this term mostly to refer to yellow and purple in this picture because I've been booted without DOM0. And in fact, DOM0 has nothing to do with the boot sequence or with the runtime of yellow and purple. Okay? But DOM0 is still there. So after the system is booted and you have DOM0 available, you can still use DOM0 to do all your operation that you will normally do. So you can use it to start another VM, red, over there on the left, use PV drivers to share a device with multiple VMs. All your normal flexibility, rebooting, stopping, etc., is still available. How does this work? So in this picture, we see well, that's actually my personal U-boot boot script, but basically what it does is, if you look at the first 4 lines, they load the device tree into memory, they load the DOM0 kernel, they load Xen, and they load the DOM0 RAM disk into memory. And the last line here, what it does is just start Xen. What I added are these 2 lines in bold here, just to load 1 more kernel and RAM disk. There is nothing particularly special about this. I just added 2 more binary to be loaded. This is a bit special instead. This is new. So there are already a few Xen configuration parameters on device tree under the chosen node, the same way there are Linux configuration parameters under the chosen node. I just extended this protocol, this device tree binding, to support more information, specifically the information about the additional VM, in the example of before, the yellow and purple VM. Why? Because you need somehow to tell Xen, you don't need to boot just DOM0, but there is also yellow and purple here you need to boot. And this is how you do it. So you add a node saying, there is 1 more domain, that's the memory in kilobyte of the domain, number of vCPU of the domain, VPL011 needs to say, please give a PL011 virtual UART, this is just for convenience. And then the presence of the kernel and RAM disk in memory where they are. Okay? So this is the way via device tree for U-boot to tell Xen what and where you need to boot. Yes, and the consequence is that Xen will discover these binaries and will load in parallel DOM0, DOM1, and DOM2 on separate cores, if you have enough physical cores available, of course. Now, it's also possible to do device assignment. Without device assignment, this would be pretty useless, to be honest with you. So you need to be able to assign physical devices to these DOM0-less VMs. So in this example today, I'm going to show a network card being assigned to the yellow VM. Since boot. So the way it's done is basically mapped into the yellow VM instead of DOM0. The way you do it is, so if you are familiar with the way we do pass-through device assignment with Xen today, what we do is we add a few parameters to the config file of the VM saying this device should be assigned to this VM. And the same goes here, except that we don't have a VM config file. Our config file is device tree node under chosen. So what we added here is just a third module, which is a little device tree snippet that contains all the information about your Ethernet device in this example to be assigned to the VM. What is in this snippet? Is the thing on the right, which is exactly the same that we use for normal device assignment on VMs that have been booted from DOM0, so nothing changes. So there is a pass-through node. Underneath, there is a node describing the device you are to assign. There are a few special properties that we need to take care of, like interrupts. Those are the interrupts that will be remapped into the VM, in this case, a yellow VM. The reg property, the Xen reg property, is to say this is a memory region that's going to be remapped into the guest. And you can even specify different addresses. So an MMIO region that at host is at address A can become address C in your guest if you want to. And that's pretty much it. So automatically Xen will boot your guest with device being assigned, opening the door to a true DOM0-less scenario where DOM0 is actually not there. Now, this is not actually implemented today, also it's trivial. It's just a matter of actually not doing something. It's certainly easier than doing something. But this is extremely common in our customers as a demand of a need. So you have maybe 2 devices that you want to really drive very well with maybe bare metal application, or 1 bare metal and 1 Linux. The bare metal certainly is not even SMP. And you want to just directly assign these devices to the VMs, and often they are just 2, or at most 4, so a very, very limited amount. So the benefit of this design are many, because without DOM0, you have no DOM0 to safety certify. That's easy. Now you only have Xen. And without DOM0, you don't have to rebuild the tools. So with this scenario, you can just take Xen from Xen.kit, build it the same way as you build the Linux kernel, so with just a cross-compiler, and that's it. And you get the binary, and it works. So no Yocto, no meta virtualization, no building of user space components at all. All right, so yeah, that was saying a consideration regarding safety criticality. So DOM0-less VMs are a great match for your real-time critical apps, because they start faster, they are independent from DOM0, and then you can still have DOM0, at least during boot, to start more VMs, but the DOM0-less critical VMs are out of the way. And one idea that we have that, again, is not implemented would be to reduce the power of DOM0 so that it cannot affect the critical VMs. So that you can still have DOM0 for the dynamic, not very important VMs and start, stop, and whatever, but the critical VMs are still there and untouchable. This is not done, but shouldn't be impossible to do. Yeah, so one thing to know is actually, is not so today you cannot do net front, net back, so PV drivers with DOM0-less VM. It's on our roadmap, but that doesn't work. So they are a great fit for device assignment. Now, but from what I've seen so far is actually most people actually care about device assignment and very little about anything else. So I think it should already cover the 80% of use cases as far as I can see. So pros and cons in general. So we have a much faster startup time, drastically faster startup time, really from 10 to 1. Enable true DOM0-less configurations that are great for simplicity, for small system, and far, far easier to certify. Lower complexity, so you only need to build Xen now, no tools. One thing I forgot to say is in the case of DOM0-less VMs, the VMs themselves don't even need to know they're running on Xen. There is no need for Xen enablement at all in your guest. So no, because we don't do PV drivers for these VMs, so you don't need to have special Xen interrupts, special Xen interfaces, nothing. So you can take a Linux built without config Xen, completely absent, and it will boot as a DOM0-less VM. Or obviously a QNX kernel, VxWorks, so there is no need for Xen support. Cons, well, you lose your powerful DOM0 environment where you can monitor, you can check for the health status, you can do a lot of things in DOM0. You know, you can't have everything, right? Right, so what is done? 4.12, which actually has been released this week, and it was yesterday or 2 days ago, I got confused with time zone, but it does already have DOM0 support, DOM0-less support. What's missing is device assignment has been published, the code is out there, but is not upstream yet because it missed the merge window. True DOM0-less is missing, but it should be really trivial to do. Another thing that should be simple to do that is in a short distant future coming will be sharing a page in memory so that the two VMs can communicate with one another. I'm not talking about PV drivers. I'm talking about something very simple, literally a page in memory, just to send messages across. And then eventually we'll get PV drivers working, but that requires a bit more work because there is some infrastructure that is in DOM0 that is required to work. It's not trivial. Okay, so I'm going to show you a bit of a complex demo. So let me explain and talk through it. So we're going to have U-boot with Xen. Okay, Xen will boot in parallel DOM0, yellow, and purple. So you're going to see 3 VMs with messages on the console all intermixing for about a second. And then you're going to see only DOM0. Why? Because the other VM are faster. At that point, the other VM have already done their job and they've stopped printing. Then you're going to see DOM0 continuing printing because it takes longer, the user space, initialization stuff. And then I'm going to log in DOM0 and start another VM, another normal VM, the same way you would do normally. That will be the red VM on the left. Just to make the thing a bit more interesting, I assign the network card, the only network card on the system, to the yellow VM. So that means I'm going to show that the yellow VM has network connectivity. In the demo is DOM1 or DOM1 has network connectivity. Nobody else has. Okay, but I also started PV backend and frontend between DOM0 and the new VM, a special pseudo network interface, paravirtualized network interface that cannot go out because there is no network card in DOM0 or in your red VM. There is no real internet connectivity, but they can talk with one another as if they were on a network, a private network of sorts. And because this is a special new protocol, actually you'll see there are some interesting consequences, like there is no network interface if you do ifconfig, and they communicate over loopback, like localhost. So literally localhost of red is connected to localhost of DOM0, which is a bit strange. So here is the demo. All right, so this is machine booting. It's going to take a little while. Sorry. So it's booting is loading the binary via TFTP in U-boot. So that's all of them. Okay, now Xen is starting. Now all the VM are starting, so a bit of a mess on the console. That's it. The others are done. Now it's just DOM0. DOM0 takes a bit longer. That's random, as you know, it takes a bit longer. Now, this is a recorded demo. So I'm logging in. So this is what I've done. So with Ctrl-A, you switch between your DOM0-less VM, Xen, and DOM0. So you rotate between them. And I just did Ctrl-A to switch to DOM-U1, so it will be our yellow VM in the picture. And I show that there is an IP address, so it's already obviously got the IP address, and that is connected to the internet. So, well, there's actually Xilinx internal network. So just to show that the internet is working, I was pinging the host, basically my workstation. So it's pinging outside. Okay, this is the only VM that has outside connectivity. Now I do Ctrl-A again a few times. One to switch to DOM-U2, another one to switch back to Xen, then DOM0. Okay, so we are in DOM0. So I'm logging in. I do an Excel list. As you can see, there is DOM0 and 2 nameless VMs. The nameless VMs are the ones that are started at boot time in parallel with Xen. In parallel with DOM0. Why they're nameless? Because the name is one of the things that come with Xen PV interfaces. So because Dom0-less is completely like so cut down and no need for any Xen special interfaces, they come out with no name at the moment, at least. Both of them has 128 megabytes of RAM. One has 2 vCPU, one has only 1 vCPU, just to show that you can set this parameter the way you like. Now, what I'm going to do is going to start a normal VM. Now, this is the config file. Well, I commented out a few lines. The important ones are the one at the top. So name is test, 128 megabytes of RAM. I specify the kernel. I specify the RAM disk, the command line parameter to the kernel. And PV calls is this strange network interface that doesn't quite look like the network, but it does. Okay. So I'm going to start this VM. This is starting. Okay, that's your third VM running, the red one. I just show that there is one more, in Dom0. I go back to the console, and what I did is I basically am starting the BusyBox HTTPD server, okay, with a page only chow is written on it. So if you see, I created like this page, right, just index.html with chow. Here it got mangled a bit, but I started HTTPD. And note that in this guest, there is only loopback. No network interfaces, okay? No real network or PV network interfaces. This is where I start HTTPD, actually. Okay, now I go back to Dom0. If config is Dom0 again, there is only loopback in Dom0 too. And I wget localhost, and there is a web page coming, and the web page is the chow web page. And that's it, so I'm open for questions.
How can I duplicate your work on which kind of hardware?
So you should be able to run Dom0-less on any platform where Xenon ARM boots. So there is really no board requirement.
So even
U-boot, that's the only requirement. Yeah.
Can I duplicate on like this notebook?
Yeah, with QEMU. Yes, you could boot it on QEMU with U-boot on QEMU, and yeah.
Okay.
Yeah.
Are the device tree mods non-standard?
So we have a set of, so we used to have a specification called multi-boot on x86. There will be a grab specification to boot more than one kernel and of generic kernel, not just Linux. We really were the only one using it. Okay, Xen was basically the only user of this grab interface. So when we were to add the ARM version of this interface, instead of trying to do the same on ARM, we added a device tree binding that we called multi-boot. But the only thing in common with multi-boot is the name. Okay, the implementation is completely different and is based on device tree. And the binding have been maintained since almost 10 years now on the Xen.git repository. Okay. And this is just a set of nodes to be used to explain where Dom0 is, and is done under the chosen node. What I only added is extending this interface. And grab supports this interface, for instance, so grab is able to add the required node dynamically at boot time if it needs to.
Okay.
I think also our version of U-boot, at least the Xilinx version, is able to add some of these nodes automatically. I don't know the upstream version of U-boot.
That's fine. So from devicetree.org's point of view, it's non-standard, but you guys maintain it.
Yes, so
right?
it's fair, yes.
That's fine. So another question, in the Dom0-less boot flow, you said that you're setting up a device tree with like a description of the system in terms of the VMs and all of that stuff. That's placed in memory by U-boot and accessed by a part of the multi-stage pathway, right? So
the description, which actually I can show because I have it here, but it's loaded in memory, normally with, for instance, TFTP-B, and then it's passed to Xen, normally as you will pass the device tree, and Xen just reads it, and that's it.
Okay.
So it's a normal extension to the existing. So this is a ZincMP device tree. Normal, no changes at the top, all the normal stuff. Now I go at the bottom, and you can see there are these. So this is normal, the Xen parameters, okay? This is normal, is DOM0. That's the famous multiple protocols I was telling you about, existing since almost 10 years. What is new are these DOM1 and DOM2 nodes with the presence of the kernel RAM disk and a few additional parameters.
Okay. So in theory, you could get the DOM-U names from the DT itself?
In theory, yes.
For your Excel?
Yes. Yes.
Would VMware like to ask any questions? Sorry.
If I say if ARM architect, right, they have MSP, things that stand-alone processor. So with this case, as long as the memory is shared, you actually can start your Xen from a totally independent, like management control.
So, yeah, so that would be actually a great fit for where those DOM0 function should go, right? So
yes.
If you have DOM0-less, now you're not able to do health monitoring, you're not able to reboot the platform, you don't know how it's going, right? So those functions that used to be in DOM0, having them on a separate processor doing health monitoring is a great fit. So this is a good way of doing it. Like if you have an external little processor, you could run a simple health checker and reboot the whole thing if needed, which otherwise you're not able to now. Yeah.
Okay, so.
You mentioned adding a page of shared memory to do VM-to-VM communication. Why can't you use virtio vsoc for that?
So even virtio vsoc, like for instance, OpenAmp is based on virtio. Now we have showed OpenAmp working on Xen. Now the underlying basic mechanism is just that you need to share a set of pages. So I guess this will be the basic stepping stone to get anything really running from virtio to PB drivers to your own library for communication or a ring, anything, you really need to share a page. So that will definitely be possible. Once we have a way to share a page, you could set up a virtio ring on it and then use your favorite virtio protocol. Yeah. So it's definitely one of the goals. Yeah. Okay, so thank you very much. Okay.
After the virtual machine put up, so at the beginning that the one virtual machine bind to one specific CPU, right? So
this is a good question. Okay, so let me go back to the slides if I still have them. So this is a good question because Xen can do it both ways. So, but for this scenario, only one I think makes sense. So you know, Xen has a scheduler. So if you wanted, you could run all 3 VM, for instance, on one physical CPU. Does it make sense? It doesn't. Okay, so I think really the best way to take advantage of this is by using the null scheduler, which is a scheduler in Xen that does nothing. So basically simply get the first physical core available and assign it fully to one vCPU, and then the next, and the next, and when you run out, you are not going to be able to run anything anymore. That's why we call it null. So if you use a null scheduler, you just pass a command line parameter to say, I want null, then immediately you will get them 0 on CPU 0, yellow on CPU 1, and purple on CPU 2. And I think even I did that. Let's see if I did it. No, I did not. Okay, I was bad. So you see, I specify sched equal credits. That means I was using the normal VM scheduler, so things could have been moved around. That's not a good idea. So you want really null. Yeah, there.
So we can group some CPUs as well.
So grouping of CPUs, it's possible today, I think, only once DOM0 has come up. So it will still work. So you will be able to, for instance, start all the DOM0-less VM with null, so static assignment. And then when you have DOM0 up and running, you can start drawing CPU pools and say, this is a pool that is untouchable, and let's have another pool somewhere else, and we have the normal scheduling pool. Today, we cannot do that without DOM0. It's one of the missing features that if we care about it in a DOM0-less scenario, we'll add it.
Just one last question. So static affinities of VMs with CPUs in a DOM0-less environment, that's possible?
Yes, with null scheduler. So if we are...
No, but at boot time.
At boot time.
Okay.
So if you here, literally, you see where the cursor is, sorry, if you write null instead of credit like I did, basically you get the behavior you just asked for, the last parameter setting. You see that one? By the scheduler, right? So this is the setting to choose your scheduler. Yes, so you cannot say, I want yellow on CPU choose specifically. No, you cannot do that. But you can say, I want each vCPU to be fully and dedicated a physical core. And you do that by doing that. So doing what you ask, you can do it from DOM0. So it's still available, it's still possible, but you have to wait until DOM0 is up. And again, there is no technical architectural reason for which you couldn't do it at boot time with DOM0-less. It's just I haven't added that parameter to DOM0-less yet.
Asymmetric systems and that stage of initialization requirements for mapping units to different processes.
So by removing DOM0, you essentially you mentioned that earlier. You removed the need to certify Linux for say if this is using an automotive setup, then Linux doesn't have to be certified ASIL 2, 3, 4 anymore, right? But you still have to certify Xen.
We just had a very useful discussion last week. So so what we're trying to do in the Xen community is to, and I know that there are not many open source projects that are going in this direction. So maybe we'll be the first, hopefully, but to enable downstream users to safety certify Xen easily. And there is a number of things that we want to do to make that happen, including MISRA-C compliance, including adding the design document and architecture specification, committing them in the Xen.git tree, so as an upstream Xen community, we're not going to safety certify Xen, but we want to give all the tools that are needed so that somebody could come in and safety certify it with a small effort, not 10 years effort, right? So this is on the table, and the discussion just started last week, and it looks very promising. There are a number of companies interested, and hopefully we'll be able to do this. Yeah. Okay. So, thank you very much.